Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. We live inside a moving solar machine and it never stops. If you've ever watched the sun long enough, one thing becomes obvious very quickly: it never stays the same. Sometimes it looks calm, almost sleepy. Hardly any sunspots, quiet surface, everything stable. And then, a few years later, it's like a completely different object. Sunspots everywhere, eruptions popping off, solar wind stronger, the whole thing basically active mode. This rise and fall is called the solar cycle, and it repeats roughly every 11 years. Or in simple terms, some people have mood swings every week. The sun takes its time and does it every decade or so. As the saying goes, even the sun has its cycles. The pattern was first seriously noticed in 1843 by a German apothecary and amateur astronomer, Samuel Heinrich Schwab. He wasn't even trying to find cycles at first, he was actually hunting for a hypothetical planet inside Mercury's orbit. He didn't find the planet, but he did notice something far more interesting: the number of sunspots goes up and down in a regular rhythm. After nearly 2 decades of tracking, he published the idea that solar activity follows a cycle. Later observations confirmed it, about 11 years on average. Since then, scientists have been counting sunspots like a long-term health chart of the sun. At solar maximum, things get loud. More flares, more coronal mass ejections, stronger particle storms. Space around Earth gets messy. In 1989, for example, a strong solar storm knocked out the entire power grid in Quebec, Canada. Millions lost electricity in under 2 minutes. At solar minimum, it's the opposite. The sun looks unusually calm, sometimes with no visible sunspots for weeks. One deep minimum happened in 2008 to 2009, and researchers actually started wondering if the sun was acting strange. In reality, it was just following its cycle. No drama, just cosmic routine. But why 11 years? The answer is buried inside the sun itself. The sun doesn't rotate like a solid ball. Its equator spins faster than its poles, about 25 days versus roughly 35 days. This is called differential rotation. Over time, this difference twists and stretches the sun's magnetic field like someone endlessly stirring spaghetti in a giant pot. Eventually, the stress builds up. The magnetic field reorganizes itself. That's when activity spikes: more sunspots, more eruptions, more energy release. But there's an even deeper layer to this story. The 11-year cycle is actually only half of the full picture. The full magnetic cycle is about 22 years, because after one peak, the sun's magnetic poles actually flip. North becomes south. South becomes north. Then after another 11 years, it flips back again. So in a way, the sun is like a gigantic machine that resets its entire magnetic system on a regular schedule. Back in 1908, George Ellery Hale proved that sunspots are tied to strong magnetic fields. And in 1919, he confirmed that the magnetic polarity actually reverses. That's how the 22-year cycle was discovered. Even today, scientists are still trying to fully understand how this internal solar dynamo really works. Some parts are still missing pieces. And the effects are very real here on Earth. During solar maximum, auroras become more frequent, sometimes even visible in places where they normally never appear. Satellites get more radiation exposure. Radio signals can get disrupted. Astronauts on the ISS face higher radiation levels. Airlines sometimes reroute flights near the poles. During solar minimum, the solar wind weakens, and more cosmic rays from deep space can actually reach the inner solar system. So even though the sun is 150 million kilometers away, we're constantly living inside its influence. And while we track these cycles, something even bigger is happening in the background: slow, but irreversible. Because the sun is not permanent. It was born about 4.6 billion years ago from a massive cloud of gas and dust in the Milky Way. Gravity pulled everything inward, heating the core until, at around 10 million degrees, nuclear fusion finally ignited. That was the birth of the sun. Since then, it has been in its most stable phase, the main sequence. For billions of years, it has been converting hydrogen into helium, steadily powering the entire solar system. If you compress its 10 billion year lifespan into a human life, the Sun would be around middle age, about 50 years old. Stable, reliable, but not young anymore. And yes, it still has roughly 5 billion years left. But nothing lasts forever. Eventually, hydrogen in the core will run low. When that happens, the Sun will expand into a red giant. Mercury will be swallowed almost immediately. Venus likely too. Earth becomes a much more complicated story. Even before any direct engulfing, the increasing heat will boil the oceans, strip the atmosphere, and turn Earth into something closer to Venus. In cosmic terms, it's not a quiet retirement. It's more like the entire building getting demolished. After that, the Sun sheds its outer layers, creating a glowing planetary nebula. The core collapses into a white dwarf about the size of Earth, but with half the Sun's mass packed inside. It will slowly cool over billions of years. But the Sun itself is not unique. There are billions like it in the galaxy. Which leads to the real question: is our Sun special, or just another ordinary star in a very big neighborhood? If you think the Sun's core is basically a 4.6 billion year old nuclear power plant, the real headache for scientists isn't there at all. It's on the surface, or rather, just above it. Because here's where things stop making sense. We all learn a simple rule early on: the farther you are from a heat source, the cooler it gets. Stand away from a fire, and the warmth fades. That's just how life works. As the saying goes, keep your distance, lose the heat. But the Sun didn't get the memo. The visible surface of the Sun sits at around 5,500 degrees Celsius, already extreme enough to vaporize most materials instantly. Yet if you move outward into its outer atmosphere, the corona temperatures don't drop. They explode. We're talking 1 to 2 million degrees, sometimes even over 3 million. Farther from the fire, somehow hotter than the fire itself. If your home heating worked like that, the landlord would have been in trouble a long time ago. Scientists have been scratching their heads over this since the 1940s. In 1941, German astronomer Walter Grotterien noticed something strange in the Sun's light spectrum signals that only make sense at extreme temperatures. That kicked off decades of confusion. One of the leading ideas came from plasma physics. In 1942, Hannes Alfvén proposed that waves could travel through the Sun's magnetic field. Think of it like shaking a stretched rope. Energy ripples along it. Inside the Sun, boiling plasma constantly jostles magnetic fields, sending these Alfvén waves outward, where they dump energy into the corona. Later observations, especially from missions like Japan's Hinode satellite in 2007, actually spotted this kind of wave activity. So that idea has real weight. But it still doesn't fully solve the puzzle. Another big piece of the story is magnetic reconnection. The Sun's magnetic field is messy, constantly twisting, snapping, and reconnecting like tangled earbuds. And when those magnetic lines suddenly snap and rejoin, they release huge amounts of energy in an instant. That process powers solar flares and coronal mass ejections. In fact, when the Sun really loses its temper, this is usually what's behind it. Even modern missions like NASA's Parker Solar Probe, which in 2021 actually flew through the Sun's outer atmosphere, have been collecting data to figure out what's really going on. Step by step, the mystery is being chipped away but not solved. And the Sun, as if to tease us, still doesn't give a straight answer. For Earth, though, the exact temperature of the corona isn't the biggest concern. The real issue is that the Sun can occasionally throw cosmic tantrums, and when it does, the effects reach across the entire solar system. It looks calm from here. Rises every morning, sets every evening. Same routine for thousands of years. But as the saying goes, still waters run deep. Back in 1610, Galileo first pointed a telescope at the Sun and noticed dark spots on its surface. We now call them sunspots. They look darker, but they're not cold, just slightly cooler than their surroundings. And they matter, because they mark regions of intense magnetic activity. When that magnetic energy snaps, you get solar flares, explosions so powerful that a single one can release energy equivalent to billions of nuclear bombs. Then there are coronal mass ejections, which blast billions of tons of charged particles into space. If one of those hits Earth, things get interesting fast. The most famous case happened in 1859, the Carrington event. A massive solar flare was observed by Richard Carrington, and about 17 hours later, a wave of charged particles slammed into Earth. The telegraph system, the cutting-edge tech of the time, went completely haywire. Some machines still worked even after being unplugged. Sparks flew. Paper caught fire. Operators were shocked. It was chaos. Auroras, usually seen near the poles, were spotted as far south as Cuba and Hawaii. People reportedly woke up thinking sunrise had come early. And that was with a 19th century civilization. Today, we're far more vulnerable. Satellites, GPS, internet, power grids, all exposed. Scientists estimate a severe solar storm could cause trillions in damage. Some transformers could take months or even years to replace. In other words, if your Wi-Fi goes down, it might not be your provider, it could be the sun having a bad day 150 million kilometers away. The funny part? The sun isn't randomly angry. Its behavior follows a rhythm, a cycle. Roughly every 11 years, it goes from quiet to wildly active, and back again. And that cycle changes everything. If you watched the sun long enough decades, even you'd notice it's not nearly as steady as it looks. Sometimes it's loud and restless. Sunspots spread across its surface like stains on a boiling pot. Solar flares erupt one after another. The solar wind picks up like a storm rolling in. And then, just like that, it goes quiet. The surface can turn almost spotless, like nothing is happening at all. As the old saying goes, calm seas hide deep currents. This repeating mood swing is what scientists call the solar activity cycle, and it lasts about 11 years on average. Think of it like this: some people change moods every week. The sun does it on a roughly 11-year rhythm, but it's been doing it for a very long time. Back in 1843, a German pharmacist and amateur astronomer named Samuel Heinrich Schwab was actually hunting for a hypothetical planet inside Mercury's orbit. He didn't find any planet. But instead, he noticed something far more interesting: sunspots rise and fall in a regular pattern. After nearly 2 decades of observations, he published his discovery. Later, others confirmed it. This strange cycle averages about 11 years. From then on, scientists started counting sunspots like clockwork. And the pattern has never stopped showing up. When sunspot numbers peak, the sun enters what we call solar maximum. Everything ramps up: more flares, more eruptions, stronger solar wind. Space near Earth gets noisy. One dramatic example came on March 13, 1989, when a powerful geomagnetic storm knocked out Quebec's power grid in just 90 seconds. About 6 million people were left in the dark. The cause? Solar activity millions of kilometers away. Then there are the quiet phases, solar minimum. During those periods, the sun can look almost blank for weeks or even months. In 2008 and 2009, it entered one of the deepest minima in a century. Scientists genuinely wondered if something was wrong with the sun. In reality, it was just taking a long breath. But why 11 years? The answer is buried inside the sun itself. It's not a solid object. Different latitudes rotate at different speeds. The equator takes about 25 days for one lap, while the poles take around 35. As the saying goes, slow and steady doesn't always mean simple. This uneven rotation twists the sun's magnetic field over time, like stirring a massive pot of spaghetti. Eventually, the magnetic field becomes so tangled that it snaps into a new configuration. Sunspots surge, flares explode, and activity peaks. But here's the twist: the 11-year cycle is only half the story. The full magnetic cycle actually takes about 22 years. That's because at the peak of activity, the sun's magnetic poles flip: north becomes south, and south becomes north. After another 11 years, they flip back again. So in a sense, the sun is like a giant engine that completely rewires itself every couple of decades. In 1908, astronomer George Ellery Hale first confirmed that sunspots are linked to strong magnetic fields. By 1919, he showed the polarity actually reverses. That's how we discovered the full 22-year magnetic cycle. And even today, the solar dynamo inside the sun is still not fully understood. It's one of those problems where the closer we look, the more complicated it gets. What's fascinating is that this cycle doesn't just stay on the sun, it reaches us. During solar maximum, auroras become more frequent and can appear far beyond the polar regions. Satellites face more radiation. Radio signals get messy. Astronauts on the International Space Station deal with higher exposure risks. Even airlines sometimes reroute flights over high latitudes. During solar minimum, the opposite happens, the solar wind weakens, and more cosmic rays can slip deeper into the solar system, increasing high-energy particle levels near Earth. In other words, even 150 million kilometers away, we are still living under the sun's influence. And while we track these cycles, something slower is also happening, something irreversible. Because no matter how many times the sun calms down or wakes up, it is not eternal. Like every star, it is slowly aging. The sun rises every morning like a reliable old worker clocking in for another shift. But its timeline isn't measured in days or years, it's measured in billions. About 4.6 billion years ago, the solar system didn't even exist. A giant cloud of gas and dust collapsed under gravity, heating up as it shrank. Around 4.57 billion years ago, the core reached about 10 million degrees, and nuclear fusion ignited. The sun was born. Since then, it has been in its longest stable phase, the main sequence, quietly turning hydrogen into helium, powering everything around it. If you compress the sun's 10 billion year lifespan into a human life, it would be around middle age. Not young, not old, just stable. Scientists estimate it has already used about half of its hydrogen fuel. But don't worry, it still has roughly another 5 billion years to go. If the sun had a social media account, its posts would probably look something like fusion stable today. Everything running normally. Same as yesterday. Not exciting, but incredibly reliable. And that reliability is exactly why life had time to develop on Earth. But eventually, even the most stable stars change. In about 5 billion years, the sun's hydrogen will run low. And instead of fading away, it will do the opposite. It will expand dramatically into a red giant. Its size will swell hundreds of times. Mercury will be swallowed almost immediately. Venus will likely follow. Earth's fate is still debated, but one thing is clear: long before any direct engulfing, rising heat will strip away the oceans and turn Earth into a runaway greenhouse world, similar to Venus today. In cosmic terms, it won't be a notice. It'll be more like the entire office getting demolished. After the red giant phase, the sun will shed its outer layers, forming a glowing planetary nebula. The core will remain as a white dwarf roughly Earth-sized, but still holding about half the sun's mass. It will slowly cool for billions of years, fading bit by bit, until the lights finally go out. And yet, in a galaxy with hundreds of billions of stars, the sun is just one among many. Which raises a final question: is it really just an ordinary star, or something more important to us than anything else in the sky? After spending so much time talking about the sun, here are a few final facts that might genuinely blow your mind. First, what you're seeing right now isn't the sun in real time. It's already 8 minutes old. The sun is about 150 million kilometers away. Light travels at 300,000 kilometers per second, which sounds insanely fast until you realize it still takes about 8 minutes and 20 seconds to reach Earth. So if anything dramatic happened on the sun right now, we wouldn't know for another 8 minutes. And here's the strange part: even if the sun somehow vanished, gravity would also take 8 minutes to update. Until then, Earth would feel nothing. As the saying goes, what you don't know can't move you. Second, contrary to how it feels, the sun is not standing still. It's actually racing through the Milky Way at about 220 kilometers per second. That's nearly 800,000 kilometers per hour. While you think you're sitting still, you're actually on a cosmic roller coaster you never signed up for. And it doesn't take a short trip either. One full orbit around the galaxy takes about 225 to 250 million years. Scientists call this a galactic year. To put it in perspective, dinosaurs went extinct about 66 million years ago. Since then, the sun hasn't even completed 1/3 of a single lap around the galaxy. If the Milky Way were a 400-meter track, the extinction of the dinosaurs would have happened when the sun had barely passed the 100-meter mark. Third, and this one really breaks intuition, the solar system never travels backward. Everything is moving, the Milky Way itself, our local galactic group, even galaxy clusters. Nothing in space is truly stationary. As the old saying goes, in motion is the only stillness the universe knows. That's also why probes like Voyager 1 and Voyager 2, launched in 1977, eventually left the solar system. It wasn't because they escaped in a traditional sense, it's because the entire solar system is already moving through space, carrying everything along like a ship crossing a cosmic ocean. From that perspective, the solar system isn't a set of planets orbiting the sun. It's more like a spacecraft, and Earth is just one cabin inside it. And here's the wild part, while you've been watching this, you've already traveled thousands of kilometers around the sun and tens of thousands of kilometers along the sun's path around the galaxy. You just didn't feel a thing, because everything around you is moving together. When everything moves together, motion disappears. But behind all these staggering numbers, everything still points back to one source: the sun. Almost all life on Earth depends on it. Plants turn sunlight into energy through photosynthesis. Animals eat plants or each other, forming entire ecosystems built on solar power. Ocean currents are driven by solar heating. Weather systems are powered by it. Even fossil fuels like coal, oil, and gas are basically ancient sunlight stored for millions of years. From the earliest single-celled life, to dinosaurs, to human civilization, the sun has always been there, quietly running the show. Ancient Egyptians worshipped it. The Maya tracked it. Chinese astronomers recorded sunspots centuries ago. Today, we monitor it constantly with satellites. Civilizations rise and fall, languages change, empires disappear, but the sun stays. Every sunrise looks the same: ordinary, predictable. And yet, it's anything but ordinary. It's a 4.6 billion-year-old fusion engine still running at full power. It lit up the age of dinosaurs. It lights up your world right now. And in just the few minutes it took to watch this, the sun has already released enough energy to power human civilization many times over. In the scale of the universe, we're just a blink. But for life on Earth, the sun has always been the oldest, most reliable force in the sky, and probably the closest thing we have to a constant in an otherwise very restless universe. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.